Today our topic of discussion is Cartesian product of sets. What is Cartesian product? So let A and B be two non-empty sets. Let A and B be two non-empty set. And then the Cartesian product of A and B is denoted by the Cartesian product is denoted by A cross B, that's equal to ordered pair of AB such that the A coming from A and the B coming from non-empty set B. What is the meaning of ordered pair? Ordered pair means if we take A cross B cross C, that's the elements are A, B, C. This ordered pair means A is coming from A, B is coming from B, and C is coming from C. So they are coming from a particular non-empty set. This is a non-empty set, this is a non-empty set, this is a non-empty set. So this is the pair of, that is pair matlab here A, B, C are a pair from where A is coming from capital A non-empty set, B is coming from capital B non-empty set, and C is coming from capital C non-empty set. So such that A is coming from A, B is coming from B, and C is coming from C. This is called the ordered pair. Now for a finite collection, what is the ordered pair? For a finite collection of sets, what is the Cartesian product of the finite collection of sets? That's if let A1, A2, An are the finite collection of non-empty set, then what is the Cartesian product of A1, A2, An? A1 cross 2 An. What is the Cartesian product of that? That is exactly equals to x1, x2, xn, such that x1 coming from A1, x2 coming from A2, xn coming from An. In particular, we can written like as x1, x2, xn, such that xi belongs to ai. This can be written like that in short form. Now starting an example. Cartesian product of, let a non-empty set A equals to 1, 3, 5 and B equals to 2, 4. What is the Cartesian product of A cross B? So the first element from A and the second element from B, this is a pair 1, 2. This is an element of A cross B, as well as 1, 4. This is the first and the second 1, 4, 3, 2, 3, 4, 5, 2, 5, 4. So these are A cross B. And what is the B cross A? B cross A, that is 2, 1, 2, 3, 2, 5, 4, 1, 4, 3, 4, 5. This is the Cartesian product of A cross B and B cross A. So example 1, this is in particular. In 2, if we take Z cross Z, then the ordered pair of sets are like as x, y, such that x belongs to Z and y belongs to Z. This is if we take two sets from Z cross Z, then we represent like this. Now we have to show that some important point of set which to be remembered. Always. The first point is every set is a subset of itself, that is a subset of A for any set. Okay, every set is a subset of itself. So 2 empty set is a subset of every set. This is empty set, that is phi is a set which is a subset of every set. Is a set which is a subset of every set. So phi is subset of any set A, for any set A. Okay, that A can be a singleton set, also be done. So the third point is, for any set A, its universal set is U. For any set A, its universal set is U. That is, A is always subset of U. U is all possible subsets. Fourth point, if A equals to phi, the power set of A is contain only one element. Fifth point, if A has n element, if A contain n element, then PA contain 2 to the power n elements. Sixth point, phi is not, this phi is not a null set. It is a set contain one element which is phi. This is one element.